Okay, good afternoon. Welcome to this session, Satellite 2013, about bandwidth efficiency and optimization. My name is Carlos Placido. I am a senior analyst with Northern Star Research, and I'm very excited to have a panel with highly regarded executives from some of the most innovative technology companies out there when it comes to ground systems and the goal of squeezing more bits out of satellite spectrum. So the way this is going to work, I'm going to be introducing each one of the speakers, and then each one will be able to provide a 5 to 10 minute presentation, and then we'll leave questions towards the end of the session. So get ready to ask any questions. We're not going to have as much time as in other sessions because we have presentations here, but hopefully we're going to be able to answer all of your questions. So right here next to me we have Mike Ashdown, who's the CTO of Sevis Systems. And we have next, on his right, we have Rick Cannon, who's the Director of Engineering of Datum Systems. We have David Nemeth, who's with iDirect. His title is Senior Systems Architect. We have Vinay Purohit, who's the CTO of Alcatel-Lucent Ventures. Next to him, we have Thomas van den Driesche. Is that okay? Who's Rick? Now, Mike of Sevis Systems.
Good afternoon, and thanks, Carlos, for moderating this session. Also, I want to thank everyone here for taking time to participate. It's a beautiful sunny day, and I thank you for being indoors listening to us. You are dedicated. Absolutely. What I want to talk about today is optimization from kind of a different perspective. Not spectral efficiency, but really from the optimization of the data itself. Sevis Systems specializes in mobile backhaul optimization. We have an optimizer product, but we also have a deep packet inspection engine that sits on core networks of mobile service providers. And what that means is we like to think about the traffic from the tower all the way to the core network, to the HLR, to the mobile switching center. And when you start thinking about that traffic, there are ways you can optimize that traffic so that you reduce the number of bits that are provided to the modems. And then you enable the modems then to do their spectral efficiency and all the wonderful things they do. But the fewer bits that they have to put on that spectrum, the less spectrum you need overall. Thanks. So there's really kind of, we look at it as kind of a holistic approach, okay? And that is let's look at the traffic that's flowing through the network. And I'm going to start from the right to the left. We look at it from a media perspective, a transport perspective, an application perspective, and a network-aware perspective. First, let's talk about the media perspective. When you look at the traffic on a typical network, you're going to look at the media. That's going to be your physical layer, your layer 2, so HDLC. The physical layer might be idle patterns on, let's say, an E1, or idle cells if it's ATM. There is no reason to transport that traffic over a satellite connection or pass it to a satellite modem. So you can achieve some optimization by removing the traffic at or bits at the media layer that you can recreate on the other side. You also need to look at the transport layer being IP, maybe TCP. There's protocols out there, robust header compression, that can be applied. That can remove your IP headers. It can actually remove your RTP headers at the session layer as well. And you can gain maybe 40 to 60 bytes of optimization per UDP packet just by applying robust header compression. So between the media layer and the transport layer, fairly significant optimization techniques can occur that can result in maybe 30 to 50% optimization of the traffic flowing through a system. But if you take a step back from there and you say, okay, I understand the traffic that's going through the system that's on the network. There are other things that you can do to optimize that. And that's really being application aware or network domain aware. On the application side, if you think about a mobile network and maybe you have a remote site where a person is calling someone from a remote site to someone else on that remote site, if your application in that scenario, it would be voice, There's no reason to allow the voice call to go all the way from that remote site back into the core network and back to the remote site. Why not be application aware, remotely switch that call at the remote site, and therefore eliminate the need to have to transport that voice over the satellite communications at all. By looking at the application layer, voice, packet service such as GPRS and Edge, you can reduce the traffic on the mobile network within the access domain by another 10 to 20% depending on the traffic. Finally, there's things that you can do from an optimization perspective that are network domain aware. What that means is if you know how a mobile network works, then you can take advantage of its behaviors to further optimize or reduce the amount of traffic that may be required to be transported over satellite. An example of that is mobile networks are designed, GSM networks in particular, they're designed to monitor and identify congestion on the radio interface. Why? It's a mobile network. We all have mobile phones. When we show up to really cool sessions like this one, we can cause congestion on a tower. When we do that, the mobile network will detect that. When it detects that, it tells your mobile phone to start using more efficient codecs. It tells your mobile phone to throttle down on the GPRS edge connections that you have with the network to prevent the congestion from occurring. Well, if you want to reduce the amount of data going through a network or going through a satellite communications link, get the network to start invoking those same procedures that it would invoke when there's congestion on the radio interface when you start to detect congestion on the satellite communication links. You do that using network-aware techniques and algorithms. Next slide, Carlos. Okay. At Sevis Systems, as an optimizer, we think data. So everything to us is bits in and bits out. The title of this session was Squeezing Dollars Out of Megahertz. So I had to change my thinking a little bit and try to think in megahertz. And so what I have up here is a couple slides. They're a little hard to see, but it's an example of a 50 remote site. Okay, and then within that 50 remote site, so think of a telecommunications network, a mobile operator, and for the fun of it, let's think of one that's maybe in the Hawaiian Islands or French Polynesia. You know, somewhere really nice. They have 50 remotes out in various islands, and those remotes are all served through satellite links. What you see here is out of those 50 sites, we're saying approximately 70 megahertz of spectrum is required to service those 50 sites. Okay, next slide. So if you take that 70 megahertz, which you'll see on the left-hand side of the screen there, if you apply some media and transport optimization techniques, you're going to drop that down to somewhere just south of 50 megahertz of required spectrum. So you're going to get somewhere between a 30 and a 50% optimization rate on the data. If you then apply application level optimization, like we spoke of earlier, where you're doing remote switching, you may achieve another 15 to 20% optimization. That drops your overall spectrum requirements down to around 30 megahertz. Then if you apply some network-aware optimization, where the network tells the mobile phones to use more efficient codecs or throttles down on GPRS and Edge, you can reduce that traffic even further and only require 20 megahertz of spectrum. At that point, the data is handed off to the satellite modem, and you're hearing a lot about how the modems apply spectral efficiency. So what you can see is it's really, if you take a holistic approach, if you start by looking at the data and you optimize the data, what you're really reducing is the amount of data that's going to the modem, therefore the amount of traffic that the modem has to pass over satellite. Thank you.
Okay. So now we have some time for questions. So please feel free to come to the front of the room. There is a microphone. Okay. And let me now go with Mike of Sevis. You mentioned Sevis is working with all these layers with solution that is application aware and physical layer aware. What are, in your views, the challenges of selling on optimization, particularly when you're dealing with telcos and mobile operators that may have different departments handle different parts of the network?
It's a good question, Carlos. And the challenge on that front is when you go to a large service provider, the groups that are responsible for transport are typically not the groups responsible for the mobile service. So what we've done is we focused our product on providing the transport groups information on how they're impacting the mobile services, and we've ensured that our optimization techniques preserve, protect, and actually make the KPIs as measured on the RNC or the BSC within the rest of the network. We ensure that those KPIs are protected, and what that results in is the transport groups are happy because the rest of the mobile network groups who are monitoring the KPIs see positive results.
Interesting. And Mike, regarding HTS, is Sevis working on any new concept or consideration?
Yes, Carlos, we are. We see HTS as an enabler for 3G and LTE offload and overflow using satellite links. So that's an area where we're quite interested in helping service providers extend the capacity of their networks.
Okay, well, thanks to all speakers and the audience here for joining us. I hope it's been useful. It's interesting that the satellite industry clearly has so much creativity that you can always go beyond and beyond in terms of the limits. So it's fun to see that there are some interesting developments and new products out there when it comes to squeezing more bits out of spectrum. So thanks again.